Hello and welcome to today's video on logical volume management, also known as LVM. So what is LVM? LVM is a storage solution that provides a way to combine any number of disks or partitions into a single file system or multiple file systems. These file systems are flexible in their layout and allow the dynamic resizing of the allocated space. The resizing allows an administrator to shrink a volume when space is no longer needed, returning it to the free pool, or grow the volume to increase storage for a user's home directory, writing to logs, or other necessities. What about mounting these file systems? We can mount the file system created on top of LVM nearly anywhere, except for boot. Although Grub version 2 supports LVM on Oracle Linux, for systems running the AMD, Intel, and ARM architecture, the bootloader cannot read LVM volumes. This limitation requires a non-LVM disk partition for the boot partition. The last feature to highlight is LVM snapshots. A snapshot provides a point-in-time copy of the logical volume, which can be mounted and then used to make a backup of a live system. Well, that's a good introduction to LVM, but how's LVM laid out? LVM consists of 4 layers. At the bottom layer, you have the physical volumes, PV, such as /dev/SDA, /dev/SDB, and /dev/SDC. These are physical disks attached to the system. Above the physical volumes is the volume group, VG. The volume group encompasses all the physical volumes in the LVM layout, whether a single disk or multiple. In our diagram, we show it includes all the physical disks. On top of the volume group is the logical volumes, LV, which functions similar to partitions carving up the volume group. And lastly, you have the file system. The file system can be ext4, XFS, RiserFS, or whatever, and contains the directory for mounting logical volumes. Great! Looks easy, right? Let's jump into a running Oracle Linux system to demonstrate some of the details we just covered. We'll use Oracle Linux deployed in Oracle Cloud Infrastructure, where we've added several additional block volumes. This demo aims to increase the available space for files and logs on the root file system. Start by reporting any physical volumes by running sudo space pvs. This command shows we have a physical volume, a partition, which is /dev/SDA3 associated with the volume group OCI volume. Then report the summary details about the volume groups by running sudo space vgs, which shows the volume group name of OCI volume with a size of 45 gig and no free space. To increase the available capacity on the root file system, we'll add the free space to the volume group and then expand our logical volume. Increasing free space in this case requires another physical volume by adding another disk or partition. Let's see what disks or partitions are available by running sudo space ls blk. The output shows 3 available disks, dev/SDB, dev/SDC, and dev/SDD. If we wanted only to use part of the disk, then use fdisk or parted to partition it. To keep it simple, we'll use the entire disk. Create the new LVM physical volume on dev/SDB by running sudo space pvcreate space /dev/SDB. Then show the newly created physical volume using sudo space pvs. Next, extend the volume group by running sudo space vgextend and passing the volume group name OCI volume and the physical volume name /dev/SDB. With the volume group extension complete, we should examine the detailed information of our volume group by running sudo space vgdisplay. The terminal shows the VG size has increased and there is 50 gig free. So far, things are going well. We can now work with our logical volumes. Get a listing of the existing logical volumes by running sudo space lvs. The results show one called OLED and the other called root. We want to increase the capacity on root, which contains our home and var directories. When extending root, we'll need to pass the full logical volume path, which we get by running sudo space lvdisplay. The command results show that the full path for root is /dev/OCI volume /root. Now extend the root logical volume by running sudo space lvextend, passing the increased size -L 50 gig and the path /dev/OCI volume /root. Verify our success by running sudo space lv display space /dev /OCI volume /root. Outstanding! We increased the size of our logical volume. So all the space is now usable, correct? Not quite. We still have to expand the file system. Before performing that step, we first need to know what file system exists on the logical volume. Running sudo space lsblk space -f shows that /dev /stb is an LVM2 member and uses the XFS file system. Next, let's do a quick disk space check with df space -h to have a reference point before the file system grows. The output shows that the LV /dev /mapper /OCI volume -root mounted at root has 28 gig. Now grow the file system with sudo space xfs _ growfs space /. That didn't take long. Running df space -h again now shows 42 gig available. We have successfully grown our usable space for files, applications, or logs. Thank you for watching.